Today we're going faster than the speed of sound.
And what better way to get there than by blowing stuff up?
So most people might be familiar with the Doppler effect, even if they don't know it. What sound does a Formula One car make, Si? Exactly, so the car's going so fast, as it's travelling towards you, the sound waves its engine's producing are actually getting compressed in front of it because it's catching up with those sound waves. And then as it's going away, the opposite's true, so that,
So it's kind of like when the object itself is travelling faster than the actual sound waves being emitted, then you break the sound barrier.
That's when you break the sound barrier, exactly,
Right.
and you get this so-called sonic boom, and jets produce this sonic boom. And booms don't come much bigger than an explosion. And I'd love to see if the explosive boom is breaking the sound barrier, and if we can measure that. So we're joined today by John from Orpha Technologies, and so this is it.
This is about 250 grams, 8 ounces actually, of PE4. That's a British military high explosive, as it's standard high explosive for miscellaneous demolition tasks.
Great, and that should give us a big enough bang to see this shockwave coming.
Certainly it should, and we've got very good conditions for it today because the air is quite damp, and that tends to give you a better chance of seeing it.
This apparently can take the blast of an RPG, so I think we'll be all right.
Yeah, yeah.
3, 2, 1.
Whoa! There we go, we got it! Hey.
And you can see that's just in front of the explosion, so that's the explosion really driving that high pressure air outwards. You're sort of condensing the air down so much that it's bending the light coming through.
Wow.
It. So the light's sort of going at different speed as it comes through. That is amazing.
I'm pretty happy we got that.
Well, what I'd love to do now is try and sort of get some markers down and actually measure how fast that's going. So to work out the velocity of the shockwave, we obviously need some distance markers. So we've got our old favourite water balloons, and I'm just going to measure this one out to about 1 metre away from where the explosive is going to be, and then slightly offset them so that the shockwave doesn't sort of get blocked by this one in front, if you see what I mean.
Fire!
Whoa! Oh, you see the shockwave there though, that looks awesome.
And actually that's the beginning of the shockwave, you can see just as it hits it. Cool, so that's about 5 frames between the balloons of that shockwave moving there. So speed equals distance over time, so in 5 frames the shockwave covered about 50 centimetres. 5 frames of 6,250 per second equates to 0.0008 seconds. So at this point it's moving at 625 metres per second, which is much faster than the speed of sound. Awesome.
Well, I've had an absolute blast today.
Hey, me too. But remember to subscribe because we're going to be back here in the quarry for more explosive action in the future and you don't want to miss it. Today on Slo Mo, we're going to be filming one of the most destructive forces on the planet.
The fire tornado. So fire tornadoes are in fact a real thing and they happen in nature on an epic scale. So today what we're going to be doing is a bit of a taste today. We're going to build a small scale experiment, shoot that in high speed, see how that goes in preparation for our mega fire tornado which is going to be coming up soon.